Hello! Now we have everything we need for the method of completing the squares, so I will finally teach you how to complete the square. Let's start. Completing the square in one variable. So the question, what are you supposed to do? So what is your problem here? The problem is that you get a trinomial, and you know trinomial is an expression of this shape. So it's a polynomial with three terms. You see, if all a, b and c are different from 0, then you have three terms: the second degree term, the first degree term, and the constant term. And if some of the numbers a, b and c, if one of these numbers is equal to 0, then you have a binomial, so just two terms, and monomial if you just get one non-zero constant. Okay, so you know that you have this kind of expression, and you want to rewrite it in this way that you get variable x only one time, and that the new expression is of this form: a, it is the same a as here, times x minus d all squared plus some new constant. So this is what you want to achieve. Why? This will be explained in the second section, but by now we just concentrate on the method. And how are we going to do this? Well, we will use the formula for the square of a sum or difference. With a equal to x, you see again that I used a and b capital letters, just to not have a confusion with this a and this b, which are here parts of our trinomial. By now, don't worry about these two. This will be explained thoroughly in video number 10. And by the way, this way of completing the square is unique, so you can do this in exactly one way. And now I will show you an example so that you see at once how it works. We have to complete the square in following cases. The first 4 of them I will show on my iPad, and the next 2 I will show on a presentation. And in each case we have an expression of this type, and we have to rewrite it to an expression which is equal to the original expression, but which is formulated in this way. And as you know, we will use these formulas. So in the case a, we don't have to do anything because it is already in this form. The variable x is appearing only once. So here we are done. Here we don't have to do anything. But just to explain the meaning of these constants, I would just want to tell you here that in this case our a is equal to 1, our b and our c are both equal to 0, because they are not at all here in this expression, right? And what about this second expression? In the second expression, our a is still what it was before. Our d is equal to 0, because here you see we don't subtract anything from x, and our k is also equal to 0. So this first case was trivial. We already had a square, right? What about the second one? In the second one, we have a equal to 1, b equal to 2, and c equal to 1. So it is really a trinomial, right? We have 3 terms. And now we want to apply this formula with a equal to x. And how do we have to choose our b in order to be able to use this formula for rewriting our expression into this form? Well, listen carefully. We want this here to be our double product. So we want 2x be equal to 2ab. It is a mistake. It should be large A, because now I need to use this formula, which capital A and capital B. So this this expression here, 2x, should be my 2ab. But large A is equal to x. So my b must be equal to 1, right? So capital B is equal to 1. And here I see that I can actually write that this is equal to x squared plus twice x times 1 plus 1 squared. And, well, it is already a perfect square, right? So I just can write that it is x plus 1 all squared. So now I'm done with this second example. And in the second example here, my d here is equal to minus 1, because you see here I subtract minus 1. Adding 1 is the same as subtracting minus 1, so my d is equal to minus 1, and my k is equal to 0, because I have nothing added to this perfect square, right? Okay, so I'm done with this next example, and now I proceed to part C, and here again I will choose my a being x, and again this term here must be equal to twice ab. But a is equal to x, and this is 6x. 6x must be equal to 2x times b. So this b has no choice. This b must be equal to 3, right? So I can write it slowly first in this way, that it will be equal to x squared plus twice x times 3, and now to complete this square, to get a perfect square, I have to add b squared, which is 3 squared, so I have to add 9. And you see here in my formula, maybe another color, which one? This one. Here in my formula I have plus 10 at the end, and here I have plus 9, so this means that I have to put plus 1, and then I have respected the equality sign, you see? And now I can write it in the following way. My perfect square is x plus 3 all squared, and then I have plus 1 behind this perfect square. And in this case, my d from the general formula, my d is equal to minus 3, because I am adding 3, and it is the same as subtracting minus 3. I have subtraction here in the formula. And my k is equal to 1. No, it is an ugly one. This is 1, because I add 1 to this perfect square. And I'm done with this one. And the next one, d, is pretty similar to the previous one, so we can use the computations there. So first we get x squared, then we get plus 6x, and then we have to complete with 9. We know this from the previous exercise, and then of course we have to subtract this 9 so that we get this 0 operation here. And at the end we have to still subtract 40, which was there from the beginning. And now we can group this perfect square together, so it will be x plus 3 all squared, and then at the end minus 40 minus 9 is minus 49. And here we have already completed the square, and when we compare this to this general form, we see that, well, a is equal to 1, as in all the previous exercises. D is equal to minus 3, exactly as before, and our k is equal to minus 49. So now I'm done with my iPad, and for the next two problems, E and F, I will show you a solution which is written on my presentation. So here you see we have some factors, 4 and 6. So here our small a is equal to 4, and here our small a is equal to 6. Okay, so we start with this one here. And first step, if you have some coefficient at x squared, is factor out this coefficient. And you see, if I factor out some factor before the entire sum, I must, in this parenthesis, divide all the terms by this element. So here is division by 4 and division by 4. You see, 2 divided by 4, it's 1/2. And now I proceed in the usual way as I did before for this one here. I want this expression here be equal to minus 2x times something. And this something has no choice, it must be 7 divided by 8. So I have to in order to complete the square, I have to add this b squared. 7 squared is 49, 8 squared is 64, so I have to add this fraction. And in order to respect my equality sign, I have to subtract it back, so that I have performed the zero operation. And at the end, I have to subtract 1/2. And 1/2, it is the same as 32 by 64. You see why I need 64, because I will pretty soon add these two fractions to each other, and you know that in order to add two fractions, I need the common denominator, and it will be 64. Okay, so now here I'm done completing the square. It is equal to x minus 7/8 all squared, and behind this perfect square, I have to subtract the sum of these two fractions. They have already common denominator 64, so I just have to add the numerator, and it is 81, right? 81. And I'm done with my completing the square. Here I have also noticed that this is simply 9 divided by 8 all squared, so I have written this in this way. And here you see, if you compare this to this expression, you see that a is equal to 4, d is equal to 7/8, and k is equal to this number times 4. And the last example here, we do this in the similar way as the previous one, by first factoring out the coefficient at x squared, and then by treating this expression as twice xb. So my b must be 1 divided by 12, if twice b must be equal to 1 by 6. So I have to, in order to complete the square, I have to add b squared, here is b squared, and in order to respect my equality sign, I have to subtract it back, so that it is a zero operation. And then this one was here from the beginning, so I just copied it. And now here I already do have a perfect square. It is x plus 1/12 all squared, and now I just have to put these two together. So here the common denominator is 12 squared, and then I have to add the numerators, right? So here in this fraction, I just have numerator 1, and after creating the denominator 12 squared here, I have to multiply this numerator of this square by 2 times 12, right? Because 2 times 6 is 12, and I need one more 12 in order to complete to 12 squared. And this is simply 25 here, right? 24 plus 1. So this is completed square. Now I'm done with this one, and if I compare it to this expression, I see that my a is equal to 6, my d is equal to minus 1/12, and my k is equal to 6 times this negative number here. So now you have seen several examples. Thank you for watching. Bye bye.